Hello students, welcome to our channel. Today we will be discussing some numerical problems from the chapter Work Energy Power. These problems have been taken from the Conscience Physics book class 10 SS. Okay, so let us see. The first problem says that a body when acted upon by a force of 10 kgf gets displaced by 0.5 meter. Then it has been said that calculate the work done by the force when displacement is in the direction of the force at an angle of 60 degree with the force and normal to the force. Okay, fine. So just first of all let us write the given informations. Force has been given and displacement has been given. So let us check on solution 1. Okay, so solution 1. Okay, let us see. Okay. So here the given information says that what are the things given. First of all, the force has been given. So force is equal to in we denote it by the letter F is given as 10 kgf. Okay, so if I convert the 10 kgf, I can say that 10 kgf is equal to 10 into 10 100 newton. Okay, so if I convert this kgf into newton, so it will be 10 into 10, that is equal to 100 newton. Okay, fine. Now, and the displacement is given as displacement denoted by the letter S is given as how much displacement is given is 0.5 meter. Okay, so 0.5 meter. Okay, fine. Now, first of all, just let us recapitulate what is the formula for work done. Now the work done can be calculated by this formula. Work done is equal to f s cos theta, f into s into cos theta. That is, it is the product of the force, the displacement, and the cosine of the angle between the force and the displacement. Theta represents the cosine of the angle. Theta represents the angle between the force and displacement. Okay. So in the first case, in the problem that has been given, in the first case, what it has been given, it is said that the force displacement is in the direction of the force. So for the first case, we can say that this theta is equals to 0 degree. Okay, theta is equals to 0 degree. Fine. Then what will be the work done? Therefore the work done can be calculated as W equals to force is 100 newton into displacement is 0.5 meter. Okay, and cos, it turns out to be cos 0 degree. Okay, so cos 0 degree, as we know, is 1 because value of cos 0 degree is 1. So 100 into 0.5, what it turns out to be 5, and then 50. So 50 joule is the amount of work done. Okay, so I think the concept is clear. Fine. Second case, what does the second case says that? The second case says that the angle is at 60 degree. The angle between the force and the displacement is 60 degree. Okay, so formula will be same, but here theta is equal to 60 degree, hence the work done will be equals to 100 into 0.5 into cos 60 degree, isn't it? So this turns out to be 50. 100 into 0.5 means 50, and the value of cos 60, as you all know, is half. So it turns out to be 25 joule. Okay, isn't it? Fine. So this is the solution of the second problem and second part. Then solution of what is the solution of third part? So I think now you can all do the problem on your own. Nevertheless, I'm just solving it for your doubt clearance. If the force is applied normal to the displacement, then what is the angle? If the force is applied normal to the displacement, then what is the angle? Then the angle is, as you know, it becomes 90 degree. When it is the word normal has been used, you can understand, or you can just take it as to be 90 degree. Okay, then in this case the work done will be as 100, this is the force, 0.5, this is the displacement. Okay, and cos 90. So what is the value of cos 90? Can you remember the value of cos 90? The value of cos 90 is 0, isn't it? Hence the work done will be 50 into 0, ultimately it turns out to be 0 joule. Okay, so this is the formula, fine. Okay, so let us now move on to the next solution. Okay, so now let us move on to the next solution. What does our next question says that? So this is the solution number 1. So I think the problem is clear. If you have any doubt or query, you can obviously ask in the comment section. We'll be happy to solve your problem. Now let us see what is the question number 2 says. Okay, question number 2 says that a man spends 6.4 kilojoule of energy in displacing a body by 64 meter in the direction in which he applies the force. So obviously you can understand one thing, that the direction of displacement and the work done is in the same direction. So it's the angle theta is 0 degree. It is clear. So okay, let us first of all write the given informations. Okay, so this is solution number 2. Solution number 2. Okay, fine. Now what are the given informations? Just let us write. Man spends 6.4 kilojoule of energy. Okay, fine. So we can write given energy spent 6.4 kilojoule. Energy spent is equal to 6.4 kilojoule. Okay, this is energy spent, fine. And you can, as you know, that in physics we consider the energy and work to be the same thing. What is energy? The capability of doing work, isn't it? So this is definitely, we can write it at this as the work done. Okay, we can write it as work done. Okay, fine. And what is the displacement? The displacement is 64 meter in the direction of the force. 64 meter. So displacement is 64 meter in the direction of force, 64 meter. So this is the, so we can consider this to be the work done W, and this to be the displacement S. Okay, fine. Now in the direction of the force, so obviously the angle theta will be 0 degree. So it has been asked what is the force applied. So theta is equals to 0 degree, as the force is applied in the direction of the force. So the first part of the problem says that what force has been applied. So as we know that work done is equals to F into S into cos theta. From this we can write F is equal to W by S into cos theta. So the value here it is given, W is 6.4. Okay, 6.4 kilojoule. So just convert it into, so just convert this 6.4 kilojoule into joule. This is because we are doing it SI units. So 6.4 into 10 to the power 3 joule. Okay, so 6.4 into 10 to the power 3 by 64, and cos 0 turns out to 1, so it's not to be considered. So 64 into 10 to the power 2 by 64, because we have taken 0 from the 10 to the power 3, we have done it 10 to the power 2, and by 64 this turns out to be 10 square, means 100 Newton. So the force applied has been, therefore the force applied has been 100 Newton. Force applied has been 100 applied is equals to 100 Newton. Okay, so this is the force applied, fine. And it has been asked in the second part of the problem, power spent in horsepower by the man. Okay, so first of all let us find the value of power in SI minutes. Time, so for we know that the formula of power is work by time. Time is 2.5 second. Time is 2.5 second. So given time T is equals to 2.5 second. So we know that power equals to work by time. So work is 6.4 into 10 to the power 3 by 6.4 into 3 by 2.5. So we make it 64 into 10 to the power 2, make it 25, and another 10 comes in here. So now it is 64 into 100 into 10 by 25. So 25 4 is 100. 64 into 4, how much it turns out to be? 4 4 is 16. 256 and 10 there is there, 2560 watt. So this is the power that you obtain in watt. Now it has been asked find out the power in horsepower. Now do you know that 1 horsepower, I think you know this, 1 horsepower is equal to 746 watt. So what is the value of 1 watt? 1 watt is 1 by 746 horsepower. So if we convert this 2560 watt into horsepower, what will be your answer? Your answer will be something like this: 2560 by 746 horsepower. Now obviously you can do the calculations, so I'm leaving the calculations to you, all of you. So please do the calculations and find out the answer and mention it in the comment section. Okay, so I'll be waiting for your answer. Fine. So I think the solution 2 is clear to all of you, isn't it? The solution 2 is clear. Okay, now let us move on to the problem number 3. The problem number 3 says that the power of a motor is 40 kilowatt. Fine. At what speed can the motor raise a load of 20,000 Newton? Okay. So let us consider solution number 3. Okay. Solution 3. Okay. So it has been given. What are the things that has been given? Given there are 2 things given, I think. One is the force has been given. What is the force? Value of force is 20,000 Newton and the power is 40 kilowatt. 20,000 Newton, 20,000 Newton, and the power is 40 kilowatt. Okay, 40 kilowatt. Fine. So 20,000 Newton, power is equals to 40 kilowatt. If I just convert it into watt, it is 40 into 10 to the power 3 watt. What we have to find out, just let me see once again. We have to find out the at what speed. It has been asked at what speed, so we have to find out the speed, isn't it? We have to find out the speed. Okay, so you know, so what formula you can use here? You know that power is equal to work done by time. Okay, now what is the formula for work done? What is the formula for work done? You know, the formula for work done is force into displacement. So power is equals to work done, so equals to force into displacement. If we consider the force to be in the direction of the displacement, then cos 0, so F into S. Now see, what is the value of this F into S? What is the value of this F into S? S by T. This S by T is actually velocity, isn't it? Displacement by time is velocity. So my formula turns out to be force into velocity V. Then velocity V you have to find out, so it is V force by the power by the force applied. So power is 40 into 10 to the power 3 by force is, I can write 20 into 10 to the power 3, isn't it? Like this I can write. There are 3 zeros after 20, so I can write 20 into 10 to the power 3 Newton. Okay, so this cancels out, the remaining is 2. So the velocity is 2 meter per second. Okay, so this is the solution. I hope the solutions are very clear to all of you. Okay, so you can easily remember these solutions and understand the solutions, and I hope this will be helpful to all of you. If you have any query in it out, please do ask in the comment section. We'll be happy to solve your problem. Okay, we'll be seeing the next video. Till then, please do study well. Okay, bye.